page 11 and 12 of descriptive statistics. We're going to start with this matching exercise. We're going to match the top half for frequency histograms with the bottom half, which are for box plots. I think it's a little easier to look at the box plots first, and especially like the weird looking box plots, which would be these two. I think these are the easiest to match. So if you look at like this first one, we can see that, or maybe the last one, you can see that like this box plot has 50% of the population smashed up into the left side, plus it's got two outliers here. So where do we see that? We see two outliers, and we see everything smashed onto the left. So, I mean, both of these two have two outliers on the right, kind of, but this one is the only one that's like smashed to the left. So I would say that B goes with 4, and 4 goes with B. Okay. What about this other one that looks kind of weird? Roman numeral 3. It's got an outlier to the left and it's got an outlier to the right. So that kind of looks like this one, right? So I would say C is 3 and 3 is C. Okay, so that leaves these other two. One of these looks like it's leaning a little bit to the left. So it's got 50% of the population kind of crushed between 1 and 4, and it's got the rest of it spread out between 4 and 8. That looks more like D, right? So D looks more like 2, where it's kind of smashed to the left. And that leaves 1, which corresponds to A. And you can use other ways of matching, like for example, in the case of A, the minimum is 2 and the maximum is 8, and that kind of matches this also, and that kind of distinguishes it from all the others. I was using kind of the median to figure out which one was which and the outliers, but you could use things like minimum, maximum, right? Okay. 11. A manufacturer of light globes claims that their new design has 20% longer life than they are presently selling. 40 of each globe are randomly selected and tested. Here are the results to the nearest hour. So they test the old type and the new type. Okay, I just put in all this data into StatEdit. You can see it here. I put it into L4 and L5, starting with 103 and 146, and I just type them all in one column just like they are here. So first of all, is the variable discrete or continuous? Well, since it's whole numbers, it's discrete, right? Discrete. Okay. Enter the data into graphics calculator. Yeah, I did that. Are there any outliers? Should they be deleted before we start to analyze the data? So remember the rule for outliers. How you find the outliers is if they are really far away from the middle 50%. And so to do that, let's figure out what the IQR is for each one. So basically what we have here in this little chart is we have the minimum, then the Q1, then the median, the Q3, and then the maximum. And so for the old data, which is this one, the IQR would be 116.5 minus 97.5, so which is equal to 19. So the IQR is 19, and for the new data, the IQR is 143 minus 124.5, which is 18.5. So to find out the limits of where we mark where the outliers start, we take the Q1 and then we add 1.5 times the RQR. So in the old case, we would have Q1 plus 1.5 times 19. 1.5 times 19, which is 28.5. I'm sorry, minus 28.5. So Q1 minus 28.5. And then for the upper limit, we would put Q3 plus 28.5. So Q1 minus 28.5 would be 97.5 minus 28.5, which would give us 69. And then for the upper limit, we would have Q3, which is 116.5 plus 28.5, which is 145. Okay, so the limits would be 69 and 145. Do we have any data less than 69? No, we don't. Do we have any more than 145? No, we don't. So there's no, for the old data, no outliers. Okay, what about the new data? So the new data, we're going to take the Q1, which is 124.5, and we're going to subtract 18.5 times 5, 1.5, which is 27.75, 27.75. And then to find out the upper limit, we're going to take 143, and we're going to add 27.75. So we'll see if we're outside of this range for any of the data. 124.5 minus 27.75 is equal to 96.75. 143 plus 27.75 is equal to 170.75. Okay. Do we have any data below 96.75? No, we don't, because 107 is the lowest. Do we have any data greater than 170.75? Yeah, well, 191 is definitely more. Is there any other number besides 191 that happens to be greater than 170.75? No, it looks like that's the only one. So, should they be deleted before we start to analyze the data? Well, remember, there are legitimate reasons to include or exclude outliers. If the outliers were an error in measurement, then you're allowed to exclude them. But in this case, we don't really know why the outlier is there, so maybe it should be included. Okay? Compare the measures of center and spread. Okay, so here I think they want us to look at the mean also. So let's take a look at that. We'll do stat. We'll do the mean for L4. So we'll do stat, calc, 1-bar stats, L4, calculate. And so X bar is 107. So for the old data, we have a mean of 107. X bar is equal to 107. And for the new data, look at L5, and it's 134. So if we compare the old globes to the new globes, there is quite a big increase in the measurement, right? From 170 to 134, it grew about 27 or something. If we look at the median, there was almost that much growth. It's about 22. So yeah, in both measures of center, we can see that there was a significant increase. What about in spread? In spread, we can see the IQR pretty much stayed the same. It was 19 before, now it's 18.5. And if we look at the range, here we have 131 minus 75, which is about 55 or so. And then here we have 191 minus 107, which is quite a bit bigger, but remember 191 is an outlier. So how about if we do a box plot to really compare one to the other? I think it would be easier to compare graphically. So, of course, the numbers we're going to use to generate the box plot are the 5 numbers: minimum, Q1, median, Q3, and maximum for each one. So I'm going to do that, and then I'll come back and show you the results. So I've marked on here a scale from 70, 80, 90, all the way to 190. And for the old data, I've marked 75, 97.5, 110.5, 116.5, and 131, which are the 5 numbers which are used to make the box plot. And for the new data, I put 107, 124.5, 132, 143, and 191 I marked with a star because it might be an outlier. And the second highest number is 164, so I marked that here. So now I'm going to make these into a box plot. The way you do that is you draw a box around the middle 3 points like that, and then you draw a median line through the middle one, and then you draw lines connecting the box to the maximum values. So I'm going to repeat that here. Okay? Alright. What conclusions, if any, can be drawn from the data? Well, you can see that the new globes definitely show that the data has increased a lot, especially like if you look at the middle 50% here and the middle 50% here, there's an increase of about 20 from each one. And although there is some overlap, the new median is almost greater than the old maximum here. So there is a significant increase, I think. Okay. So I think that's pretty much it for this one. And the next page is 12. Okay, here we can see a different way to show the data that we've been looking at up to now, called a cumulative frequency graph. Cumulative frequency graphs also show median, first quartile, third quartile, or also called lower and upper quartile. They have usually a curved shape where you start kind of at 0 and you increase to the maximum value, steadily going upward. And you can use this graph to take your frequency, which is on the y-axis, and translate it to specific values, which are on the x-axis, and vice versa. And we'll show you how to use these now. So let's first answer or fill in some blanks about what cumulative frequency graphs do. So cumulative frequency graphs show the number or proportion of data that lie above or below a particular value. The points in a cumulative frequency graph are joined by a curved line. A percentile is a score which indicates the percentage of data that lies at or below that level. Lower quartile can also be called 25th percentile, and the median can also be called the 50th percentile. And show by drawing lines on the graph to the right how you would find the finishing time of the 50th best runner. Okay, so let's take a look at this graph. This graph is showing the marathon finishing times for 70 runners. How do I know it's 70? Because the number here, the highest value on the frequency axis, is 70. So the 70th runner took this long, which is the longest time, 2 hours and something minutes, close to 3 hours. And the fastest runner took this time, 2 hours and 26 minutes. So the 50th best runner you would find by taking this number here, 50, and making a horizontal line to the right. And then when you hit the curve, you're going to go down to find the time that corresponds for that runner, which is 2 hours and 38 minutes. So let's write that down. 2 hours and 38 minutes. If the 99th percentile indicates the slowest runner, what is the approximate time for the runner at the 75th percentile? Right? Because normally you would think 99th percentile, that sounds really good, it should be the fastest runner. But in this graph, the 99th percentile is here, and it corresponds to the person who ran in the slowest time. So what would be 75th percentile? Well, here, if this is 99th or close to 100th percentile, then the 50th percentile would be half of that. It would be like 35. And so what would be 75th percentile? Well, we take 0.75, multiply times the total number of people, 70. We get 52.5. And then that would be about there. And then we would find that the time corresponding to the 75th percentile would be somewhere between 2 hours and 38 minutes and 2 hours and 42 minutes, a little bit closer to 2 hours and 38 minutes than 42, so I would say maybe 2 hours and 39 minutes. So I'm going to put here 2 hours and 39 minutes. Okay. Let's move on to our first problem. The examination score of a group of students are shown in the table. Draw a cumulative frequency graph of the data and use it to answer the following. Find the median examination mark, how many students scored 65 marks or less, etc., etc. Okay, so what's the first step to making a cumulative frequency graph? Well, as you can see from the name, cumulative is an important part of it. And we looked a little bit before about how you make a cumulative frequency column in your frequency table. So why don't we do that first? We'll make a cumulative frequency column. And the way you do that is you just make a cumulative, you just add cumulatively all the frequencies from start to finish. And so you can see here that I'm adding all the numbers in the left column to get the numbers in the corresponding right position. So let's see, 146 and 149. Okay. Okay, so I now have the cumulative frequency which corresponds to this frequency. In order to start answering these questions, I need to actually make the cumulative frequency graph. The cumulative frequency graph is going to have the cumulative frequency here on the left side, and across the x-axis on the bottom, I'm going to have the scores. So the scores are going to range from 0, 10, 20, 30, etc., and I'm going to label all these. And the cumulative frequencies are going to go from 0 to 150, and I'm going to label all these, and then I'll be right back. Now that I've labeled the scores axis and the cumulative frequency axis, now I'm going to start plotting some of these points. How do I plot these points? Well, I'm going to plot this column with this column. But again, like, how do you know if you plot it with the x equals 10, x equals 20, x equals 15? What do you use? Well, in this case, we're going to use the right value here, 20. Okay? So, and you'll kind of see why we do that in a second. But so the first one, I'm going to graph 20, 2. So 20, 2, it would be kind of like there. 30, 7, it would be kind of there. 40, 14, it would be like there. And I'm going to finish these up, and I'll be right back. Okay, now you can see that I've graphed these numbers here against these numbers here. And now I'm going to draw a curve through these points. And the first point I'm going to graph, which isn't really on the table, but we're going to put it here, is going to be 10, 0. Okay, so we're going to start at 10, 0, and then we're going to gradually move up with our curved line. And this is going to be a sketch, because you can't draw a curved line very well. You have to sketch it. Okay, so there is our cumulative frequency curve. Now we're going to answer the question, find the median examination mark. So the median mark would be that which is scored by the middle person, which is the 75th person, which is right there, right? So we're going to take the 75th person, and we're going to follow along till we hit the curve, and then we're going to go down and see about what number that corresponds to. And we can see that it corresponds to about a 63. So let's say that is about a 63. How many students scored 65 or less? I would say about, it's 65 is about the median score, which is 63, right? So maybe we would say that it would be half the students. So half the students would be 75 students, right? How many students scored at least 50 but less than 70 marks? Okay, so at least 50 but more than 70. So let's mark that here. We're going to mark it with orange. At least 50 but less than 70. So that would be this region here, right? So let's see what that corresponds to on the y-axis. So that would be here, about a 35. And then the other point here would be here, about 110. Okay, so we're talking about this region here. And so that looks like it's about 100, from the 40th student to the 110th student, that's the difference of about 70 students. So about 70 students scored between 50 and 70, right? Okay, if the pass mark was 45, how many students failed? So 45 is about here. And let's see where that corresponds to on the number of students. It's about there. It's about 24 maybe. So if passing people would be anybody to the right of this line, right? So that corresponds to anybody above the 24 mark. So that would be, or the 24 students. So the 24th to the 150th student passed. So, or how many students failed, it says. Oh, so failed would be anywhere below 45, below 45, and that would correspond to anybody below 24. So that would be 24 students, right? Okay. If the top 16% of the students were awarded credits, what was the credit marks? Top 16 students, 16%. So 16% of the students would be 16% times 150. How do you do that? You do 0.16 times 150, and that gives you 24. So 24 students. The top 24 students got credit. The top 24 students would correspond to from here to about here. So these students here who got the highest scores got credit. What was the credit mark that they needed to attain to get credit? And so that would be about here, which is about 75. 75. Okay? So we'll put 75. Alright, so you see how you use that? Whenever they ask you something that's on the y-axis, then you draw a horizontal line until you hit the curve, then you go down and see what the corresponding mark is on the score. Every time they ask you about a score, you look at the x-axis, you draw a vertical line up till you get to the curve, and then you draw a horizontal line from that point until you intersect the y-axis, and you see which student corresponds to that score. The only trick is knowing if you look above, if you look below, if you look left, or you look right, and you have to carefully read the text to know if you're talking about below that mark or above that mark. Right? Okay, and I think that's it for this page.